Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The Siddhantasiromani macron NTA is a cute IRONA letter 1E47I, composed by Bhaskara II 2150 Common Era, stands as a monumental achievement in the history of Indian mathematics and astronomy. This comprehensive treatise, whose title translates roughly as Crown of Treatises, represents a culmination of centuries of Indian mathematical and astronomical thought. The present essay embarks on a detailed critical evaluation of the Siddhantasiromani macron NTA's acute IROMA letter 1E47I, examining its core claims, methodological approaches, and logical structures section by section. This analysis will delve into the specifics of Bhaskara's arguments, considering the evidence he presents and assessing the internal coherence of his reasoning. The aim is to provide a comprehensive understanding of the Siddhantasiromani macron NTA's acute IROMA letter 1E47I's strengths and weaknesses, its lasting contributions to the fields of mathematics and astronomy, and its significance within the broader intellectual landscape of medieval. In Section 1 Golodhya concerning the sphere. The Golodhya, or chapter on the sphere, represents the initial exploration into astronomical concepts within Siddhantasiromani macron NTA's acute IROMA letter 1E47I. Bhaskara commences by establishing a foundational framework of spherical trigonometry, essential for accurately representing celestial movements. A central claim presented involves the precise determination of celestial coordinates, incorporating refinements to previously established methods. Bhaskara elaborates on calculating the positions of celestial bodies based on their declination, right ascension, and latitude. The methodology employed here relies heavily on geometric proofs and visualization, leveraging established relationships in spherical geometry. For instance, he meticulously details the derivation of formulas for converting between ecliptic and equatorial coordinates, a crucial step in predicting planetary positions. He offers a method to calculate the true position of a planet in the sky after accounting for parallax and atmospheric refraction. The evidence presented consists primarily of geometric arguments and algebraic derivations, demonstrating the internal consistency of these formulas. Critically evaluating this section, one observes Bhaskara's masterful manipulation of trigonometric identities and his ability to translate these into practical computational techniques. It is a testament to his profound understanding of spherical geometry. Section 2 Geometry. J letter 1 E411 letter macron DHY macron Y planetary mathematics. The GRAHADA letter 1 E47 ITA macron DHY macron YA, focusing on the calculations of planetary positions, dives into elaborate mathematical models designed to predict the movements of celestial objects. Bhaskara propounds theories concerning the epicycles and eccentric circles, elaborating on the established Indian astronomical system. A key claim pertains to the accurate prediction of planetary longitudes, aiming to refine earlier models through incorporation of additional corrective terms. The methodology involves defining parameters for each planet, including their mean motions, apstal points, and nodal points, and then employing elaborate algorithms to calculate their positions at any given time. He offers multiple methods to calculate the true positions of planets, using both the epicyclic and eccentric models, discussing the advantages and limitations of each approach. The evidence presented comes primarily from comparison against observational data. Bhaskara does also detail methods for determining planetary parameters by analyzing observed positions of these bodies, showcasing a reciprocal relationship between theoretical models and empirical data. A critical evaluation reveals that while Bhaskara advances the precision of planetary calculations, the underlying geocentric model remains burdened by inherent complexities. The sophistication of the mathematical apparatus, however, is undeniable. Section 3 Lilavati. The beautiful Lilavati. The first part of Siddha Macron NTA is acute IROMA letter 1E47I, deals with arithmetic, algebra, geometry, and trigonometry. It presents these mathematical concepts through a series of illustrative problems, often framed within engaging narratives or poetic verses. Bhaskara lays down fundamental arithmetical operations such as addition, subtraction, multiplication, and division, extending these to include squares, cubes, square roots, and cube roots. A central claim involves the efficacy of his methods in solving practical problems related to commerce, measurement, and other facets of daily life. The methodology employs a combination of rules and examples, each carefully designed to elucidate a specific mathematical principle. He presents an algorithm for solving indeterminate equations of the form x plus by equals c, where a, b, and c are integers, an insightful contribution to number theory. The evidence for this claim comes primarily from the success of these methods in resolving the posed problems, demonstrating their internal consistency and practical applicability. Critics note the absence of formal proofs in the modern sense. Its enduring legacy comes from its engaging presentation and its accessibility to a wider audience. Section 4, B I Macron J letter 1E47 ITA Seed Arithmetic. The B I Macron JAGA letter 1E47 ITA, translating to seed arithmetic, delves into the realm of algebra, expanding on the foundations laid in Lilavati. Bhaskara explores topics such as linear and quadratic equations, indeterminate equations, and the properties of zero. A primary claim within this section emphasizes the ability to solve a wide range of algebraic problems using his methods, particularly those that are intractable through purely arithmetical techniques. The methodology employed here involves introducing symbolic notation and algebraic manipulation as powerful tools for problem solving. He gives explicit formulas for solving quadratic equations, including consideration of both positive and negative roots, recognizing the importance of both solutions. He also discusses techniques for solving systems of linear equations and indeterminate equations, demonstrating a sophisticated understanding of algebraic principles. Evidence supporting these claims arises from the successful application of these methods to resolve complex algebraic problems, illustrating their versatility and power. Contemporary scholarship highlights the significance of B I Macron JAGA letter 1E47 ITA in contributing to the development of algebraic methods in India, predating similar developments in Europe. Section 5 GA letter 1E47 I2. A Macron DHY, A Macron by Mathematical Astronomy. The J that 1E47 Italy A Macron DHY A Macron Y A portionity A did DH A Macron and T is acute AROMA letter 1E47 contains several mathematical techniques for astronomical calculation. Bhaskara covers topics such as eclipses, conjunctions of planets, and the determination of geographical locations. A central claim involves the increased accuracy and precision of astronomical predictions achievable through his methods. Compared to earlier approaches, his methodology integrates advanced mathematical techniques with astronomical observations, striving for a synthesis of theoretical models and empirical data. He details methods for calculating eclipses of the sun and moon, taking into account the effects of parallax and atmospheric refraction. He also proposes techniques for determining latitudes and longitudes of places on Earth using astronomical observations, contributing significantly to geography. The evidence is presented through comparisons against observational data, demonstrating the enhanced accuracy of his predictions. A critical perspective appreciates Bhaskara's commitment to combining mathematical rigor with empirical observation, striving for a more complete understanding of the cosmos. Section 6 Description of Measuring Instruments. Bhaskara dedicates a part of the Siddha Macron NTA's acute IROMA letter 1E47I to describing various astronomical instruments used for observation and measurement. He explicates the construction and usage of instruments such as the armillary sphere, the quadrant, and the nomen. A central claim resides in the practicality and effectiveness of these instruments in obtaining accurate astronomical data. The methodology involves providing detailed descriptions and diagrams of each instrument, along with instructions for their proper use. He explains how to use the armillary sphere to measure celestial coordinates, such as declination and right ascension, allowing astronomers to accurately locate celestial objects. He illustrates using the quadrant for measuring angular distances between stars and planets. Support for this claim emanates from the instrument's capacity to generate reliable data when used correctly, as demonstrated by various astronomical observations. Scholars recognize the practical utility of this section, providing a valuable resource for astronomers and instrument makers alike. Section 7 Proof of the Earth's spherical shape and motion. Bhaskara presents arguments and evidence supporting the assertion that the Earth is spherical and that it rotates on its axis. He uses observations of celestial phenomena, such as the rising and setting of stars, to demonstrate Earth's spherical shape. A main claim revolves around the consistency of these observations with a spherical, rotating Earth, as opposed to a flat, stationary Earth. The methodology employs reasoned arguments and logical deductions based on observational evidence to support his claims. He discusses how the apparent motion of the stars can be explained by the Earth's rotation, thereby obviating the need for stars to revolve around the Earth at tremendous speeds. Evidentiary support comes from the coherence of these explanations with observed celestial events, forming a comprehensive model of the cosmos. Critics acknowledge that while Bhaskara argues for Earth's rotation, maintains a largely geocentric worldview, in line with prevailing astronomical. Section 8 The Nature and Cause of Eclipses. Bhaskara offers a detailed explanation of solar and lunar eclipses, outlining the causes and predicting their occurrences. He accurately describes the eclipses as the result of the moon passing between the sun and Earth, or the Earth passing between the sun and moon. This section's central claim concerns his accurate explanation of eclipses based on the relative positions and movements of the sun, moon, and Earth. His methodology employs geometric models and calculations to predict the timing and duration of eclipses, and involves detailed calculations of the positions of the sun, moon, and Earth to predict the occurrence of eclipses, accounting for the effects of parallax and atmospheric refraction. Evidential support is derived from the model's success in predicting eclipses with reasonable accuracy, thus validating the underlying principles. Scholars view this section as a valuable contribution to eclipse prediction, demonstrating a sophisticated understanding of celestial mechanics. Section 9 Longitudes and Latitudes of Planets. Bhaskara explains the computation for determining the longitudes and latitudes of the planets, crucial for accurately locating them in the sky. He provides formulas and methods for calculating these coordinates based on the planet's orbital parameters. A central claim regards the increased precision in determining planetary positions achievable through his methods. His methodology involves combining astronomical observations with mathematical models, leading to more accurate predictions of planetary positions. He details methods for converting between ecliptic and equatorial coordinates, facilitating the transformation of planetary positions between different coordinate systems. Support for this claim stems from the greater accuracy of the resulting calculations compared to earlier methods, showing the effectiveness of integration of observations and mathematical modeling. This section is regarded as a significant advancement in planetary positional astronomy, demonstrating Bhaskara's expertise in applying mathematical techniques to astronomical problems. Section 10 on the crescents of the moon. Isacute letter 1 E5 B letter 1 E4 5 Ganati. Bhaskara elaborates on the phenomenon of lunar crescents, explaining how to calculate the visible portion of the moon based on the relative positions of the sun, moon, and Earth. He presents a geometric model to describe the illuminated portion of the moon as it waxes and wanes. A primary claim here focuses on the ability to accurately predict the shape and size of the lunar crescent at any given time. His methodology involves using trigonometric calculations to determine the angle of illumination of the moon, Based on the relative positions of the Sun, Moon, and Earth, he offers methods for calculating the altitude and azimuth of the Moon using spherical trigonometry, essential for predicting the visibility of the lunar crescent. Evidential support arises from the model's success in matching observed lunar phases, confirming the validity of the underlying geometric principles. This section is appreciated for its detailed treatment of lunar phases, revealing Bhaskara's deep understanding of the geometry of celestial illumination. Section 11 Astronomical calculations related to time. Bhaskara delves into calculations pertaining to time, including determining the length of the day, the rising and setting times of the sun, and the duration of different seasons. He provides methods for converting between different time units and for determining the dates of solstices and equinoxes. The main claim concerns the accuracy and consistency of his methods in determining various time-related parameters. His methodology integrates astronomical observations with mathematical formulas, allowing for precise calculations of time intervals and seasonal variations. He explains how to calculate the length of the day and night at any given latitude, taking into account the effects of the Earth's axial tilt. He also lays out methods for determining the timing of solstices and equinoxes, crucial for calendrical calculations. Evidence supporting this claim comes from the alignment of his calculations with observed astronomical events, demonstrating the reliability of his methods. This section showcases Bhaskara's expertise in timekeeping and calendrical calculations, demonstrating his mastery of the relationship between astronomical phenomena and time. Section 12 on conjunctions of planets. Bhaskara explores the conjunctions of planets, describing the conditions under which planets appear to align in the sky. He presents methods for calculating the times and positions of planetary conjunctions. The primary claim asserts the accuracy and precision of his calculations in predicting planetary conjunctions. His methodology involves using planetary orbital parameters and mathematical models to determine when planets will appear close together. He presents formulas for predicting the positions of planets at any given time, allowing for prediction of when planets will appear to be in conjunction. Evidential support is rooted in the model's success in predicting conjunctions with reasonable accuracy, validating the underlying principles of planetary motion. This section is considered an important contribution to planetary astronomy, allowing for the anticipation and study of planetary alignments. Section 13 Cosmography and Geography Bhugola. Bhaskara includes a section on cosmography and geography Bhugola, describing the Earth's shape, size, and its place in the cosmos. He discusses the division of the Earth into continents, oceans, and mountains and presents methods for determining geographical locations. A central claim focuses on his accurate representation of Earth's geography and its position within the overall cosmic structure. His methodology blends astronomical observations with geographical knowledge, aiming to create a comprehensive model of the Earth and its environment. He also examines different theories about the size and shape of the Earth, drawing on observations and mathematical calculations. Evidence sustaining this claim arises from the consistency of his descriptions with known geographical features and astronomical observations. This section is valued for its presentation of geographical knowledge within an astronomical framework, demonstrating the interdependence of these disciplines. Section 14. The computation of signs Jaya Utpatti. Bhaskara delves into the calculation of signs, a fundamental aspect of trigonometry essential for astronomical calculations. He presents methods for constructing sine tables and for calculating sine values for various angles. A key claim lies in the accuracy and efficiency of his methods in generating sine values. His methodology employs geometric constructions and iterative algorithms to approximate sine values, using the radius of a circle as the sine of 90 degrees. He provides multiple methods for approximating sine values of different angles, demonstrating a sophisticated understanding of trigonometric principles. Evidential support is derived from the close agreement between his calculated sine values and modern values, verifying the reliability of his methods. This section is acknowledged for its contribution to the development of trigonometric techniques in India, forming a basis for later advancements in mathematics and astronomy. Section 15 Treatment of Astronomical Problems Triprasnadikara. Bhaskara addresses various astronomical problems throughout the Siddha Macron NTA is acute IROMA let Wali 47I, consolidating his methods in a dedicated section. The central claim emphasizes the efficacy of his consolidated methods in solving complex astronomical problems. He presents numerous example problems demonstrating his methods for solving astronomical calculations, demonstrating his mastery of both theory and application. Evidential support stems from the model's success in predicting these problems with increased accuracy, validating the integration of observations and mathematical models. This section highlights Bhaskara's commitment to providing practical tools for astronomers to tackle real-world challenges, showing the broader applicability of his work. Section 16 Conclusion and Significance. The Siddha Macron NTA acute IROMA let Wali 47I represents a landmark achievement in the history of Indian mathematics and astronomy. Through detailed evaluation of claims section by section, Bhaskara's work demonstrates a profound understanding of both theoretical principles and practical applications. His methods for calculating planetary positions, predicting eclipses, and solving astronomical problems reveal a deep engagement with both mathematical rigor and empirical observation. While some aspects of his work are rooted in a geocentric worldview, its mathematical sophistication is undeniable. The Siddha Macron NTA is acute IROMA letter 1E47I has had an enduring impact on the development of mathematics and astronomy in India and beyond. It stands as a testament to the intellectual creativity and scientific achievements of medieval India. Its pedagogical value, stemming from its clear explanations and illustrative examples, continues to inspire scholars and enthusiasts to this day. The work endures as an important source for those interested in the history of science and the development of mathematics and astronomy in a global context. Its structure presents complex material logically and in an accessible manner. Bhaskara II comprehensive exposition and meticulous methodology ensured that the Siddha Macron NTA is acute IROMA letter 1E47I would become a standard reference work for generations.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.